are you all? I am Siddhartha and I welcome you to your YouTube channel Study Simplified. So, this is going to be the continuation video of the digital image processing lecture series. So, in the last one, we have seen about the zooming, and today we are going to discuss the gray label transformation in digital image processing. Okay. So before we move further, I have one question. Like, have you ever noticed how the medical X-ray images and your satellite images or your night photos look clear after processing? So that clarity doesn't come from the zooming, it comes from the gray level transformation. So in this video, we shall learn how simply mathematical function can dynamically improve the image visibility. So let's get started. So for that, I have to go to my notepad. So just hold a second. Okay. So before we start, I want to show you some picture so that you can understand the overall what we are going to see in the today's video. So I am pasting some photos so that you can understand it in more clear way. So yeah, in this you can see this is our original image. Okay, so this is our original image, and we are applying some transformation in this image, like your negative of the image. So in the negative, basically, just we are reversing the pixel value. Later on, we will discuss it in detail, and the log transformation and the gamma transformation also. So this is all what we are going to see in the today's video. So let me see you some more examples. Yeah, so you can see the another example. So here it's given like the original image, and this is our original image, and this is the negative of that images. This is the same, but it is the negative. So that here you can see like how we are improving the images quality using the transformation. Okay. So that's all what we are going to discuss today. So let's understand first what is grade level transformation. Okay, so we will write like what are grade level transformation. So the grade level transformation are the special domain of the image enhancement technique. So they operate directly on the pixel intensity value. Okay, so in this, the location of the pixel is not changed, only the intensity is modified. Okay, so let's write this point is your gray level, gray level transformation are a special domain of image enhancement technique. Okay, it is the special domain of the image enhancement technique. So in this, it operates directly on pixel intensity values. Okay, so in this there is the one more most important point, like it does not change the pixel location. So pixel location, pixel location is not changed, only intensity is modified. Intensity is modified. Okay, so this is about the gray level transformation. So let's understand the mathematical representation of this. So the let me change the color. So the mathematical representation. So mathematical representation is something like S is equal to T of R. Okay. So here we will understand like what is S, T, and R. So S is your output pixel intensity. R is your pixel, input pixel intensity, and what is T? T is your transformation function. Okay, transformation function. So this is about the mathematical representation of the gray level transformation. So now we'll understand like what are the need of the gray level transformation is, like why we use the gray level transformation. So let me make the topic. So it is why gray level transformation are needed. Okay. So basically it improves the contrast. Okay. So improve contrast and it enhance dark or brighter, dark or brighter region. And the next one, like it reveals the hidden detail also. Okay, it reveal hidden detail, hidden details. Okay, and where we are using it, so we can use it in the medical and your satellite and your low light images. Okay, so this is about the gray level transformation. So now we'll discuss its type. Okay. So basically there are four types of the gray level transformation which we are going to discuss one by one. So the first one is your image negative transformation. Okay. So the first one is your image negative transformation. Okay. So the formula, or you can say the mathematical representation for this is S is equal to L minus 1 minus R. Okay. So in this, what happened? The dark areas become bright, and bright area become dark. Okay. So in the negative transformation, generally what happen? I'm giving you one example. Okay. So suppose here is your binary image 1 0 1 0 0 1 0 1 1. Okay. So in this, what will happen if you will apply the negative transformation? So it will give you output something like this. So it output will be, if there is one, it will become zero, and zero will become one. Okay. So something like this, it will give you the output. So just focus here. So what happened? The dark area. 0 is your dark. Okay, so it becomes bright. Okay, and 0 is a dark and it become bright. Okay, and 1 is bright, which become dark. Okay, so this is very simple transformation in the image process. So the application will be your medical imaging. So let me write it down. So the application will be your medical imaging in your X-ray and your MRI. Okay, and the next application is your enhancing the white or gray details. Okay, so enhancing white or gray details. So just take an example to understand it. So in the black background of the X-ray, the white background with the clear bones. Okay. So so here you can see like in the black background. So the background is fully black and the white bones is reflected here. You can see it. Okay. So here we can use the negative transformation. Okay, so this is how in the medical images we are using the negative transformation. So the next transformation is the log transformation. Okay, so let's move further to the log transformation. It is the second type, log transformation. So the mathematical representation is something like S is equal to C log 1 plus R. Okay, so let's understand it. So in this, basically what happened? It expand the low intensity pixel. Okay, so it it expands low intensity, or low intensity means the dark pixels, and it compress high intensity or your bright pixels. Okay, so let's take the application of the log transformation. So the application is your Fourier spectrum visualization. So application. So application is your Fourier spectrum visualization. And the next application is your image with very large dynamic range. Okay. So these are the two application of the log transformation. So let's understand one example. So example you can consider like dark satellite image, and we are applying the transformation and it gives the details. Okay, become visible. So what are the hidden details of the image is become visible. So this is all about the log transformation. So the third one is your power law. Okay, so power law, or you can say the gamma transformation. So let me go to the next page. Make our heading is the third type is your power law, or you can say gamma. Okay, GAMMA, gamma transformation. Okay, so the formula, or you can say the mathematical expression for this is S is equal to C dot R to the power gamma. Okay, so let's understand the what is the impact of gamma value. Okay, so if the gamma is less than 1, what it means? The image become brighter, and if the gamma value is greater than 1, it means image become darker. Okay, so this is the effect of gamma in the gamma transformation, or you can say the power law transformation. So let's see the application. So application. So it can be used in your display system, used in display system. Okay. So display system means your TV, or you can say the monitor or your mobile screen, etc. And the next application for this you can consider the camera correction. Okay, camera correction. Camera correction, or you can understand it as a gamma correction also. Okay, so example is your mobile camera brightness adjustment. Okay, so let me write it down. Mobile camera brightness adjustment. So you have seen like when you are clicking some images, so there you have option so that you can according to your expectation you can fix the brightness of, and you can say you can adjust the brightness of the camera. So there the power law, or you can say the gamma transformation works. Okay, so the last one is your piecewise linear transformation. Okay, so the fourth one is your piecewise linear transformation. So what is this? So basically, the idea behind this is like image is enhanced using the straight line segment. Okay, so the image is enhanced using straight line, straight line segment. Okay, so it can be used when only a specific intensity range need enhancement. Okay, so suppose there is an image. Okay, so suppose this is an image of a boy. Okay, and you have to enhance their face. Okay, so you have to enhance this region. So you will use piecewise linear transformation. So in this, there are basically three types. So types. So the first one is your contrast stretching. Contrast stretching. Contrast stretching. and the next one is your thresholding, and the last one is your gray level slicing. So if you talk about its application, so application are like highlighting the specific objects. So let me write it down. So the application is your highlighting, highlighting a specific object, and another is improving contrast in low quality image. Okay, so this is about the application of the piecewise linear transformation. So, for example, we can use it in the enhancing the text in the scanned document. Okay, so now we will do the quick comparison between all of the transformation which we have learned so far. So the first one we have talked about the negative transformation. So the purpose we are using in this is like just we are reversing the intensities. Okay. So application we have seen like in the medical image, in the X-ray I have shown you one figure. And the next one we have understand about the log transformation. So in this the purpose is like enhance the dark pixel. So the application we have seen like the spectrum analysis. And the next one we have understand about the log gamma transformation. So in that, just we are focused on the brightness control, just as your display and your camera. And next one, we have understand about the piecewise transformation, in which we have discussed the contrast enhancement, like in the specific region, if we have to enhance or we have to highlight the portion so that we can use the piecewise transformation. So that's all about the today's video. We have understand the gray level transformation and their four types. So we have understand like images can be enhanced without zooming or resizing just by transforming the pixel intensity. So in the next video, we shall go deeper into the histogram processing where enhancement depends on the distribution of pixels value. If this value helped you, like, share, and subscribe to Study Simplified for the more digital image processing content. So don't forget to share it with your friends. Tab tak ke liye keep watching and keep learning. Bye bye.